Hello friends, welcome to my channel Academic Made Easy Peasy. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning Chapter 5 Continuity and Differentiability, Exercise 5.2. So all these formulas were taught in the introduction part of this chapter. If you have not watched that video, you can watch it. Those who have watched, you can just take a note of it or just recall it. Differentiate the functions with respect to x. So we have already learnt about differentiating in the introduction part as well as in class 11. I think this will be easy. So this first exercise, we have 10 questions, so we will be using chain rule in this exercise. So I think you know what is chain rule. If not, I will teach you what is chain rule. So already I have taught you in the introduction part what is the derivative. Derivative means, for example, see, let us take this as, always you just take this as y is equal to the given function. Okay, so sine of x squared plus 5. So this is a given function. We have to differentiate this only. So what we will be doing is that we will be taking d and we have to take this variable. Okay, differentiate the functions with respect to x. Okay, so only with respect to x we have to do. So we will be writing it as d by dx. Okay, d by dx means we are differentiating the function with respect to x and this variable as it is. So you can write it as dy by dx also, or else d by dx of y also. You can write anything you can write. So here also you can write it as d by dx. Okay, d by dx of sine x square plus 5. Okay, so now what we will be doing is that this is sine of something like sine theta. Yes, so this is the one function, whole function. So what I will do is that we know the formula d by dx of sine theta is equal to cos theta. Yes, so here what is theta here? Theta is this value here. Theta is equal to x square plus 5 here. Okay. So what I will do is that dy by dx is equal to cos of, what is the theta here? It is x square plus 5. So you should not stop till here. See, for sine it is over. For theta, this is this value. We have some value, isn't it? We have some variable here, that is x square. So we have to differentiate that. So we will be taking d by dx of x square plus 5. Okay. So write dy by dx is equal to this as it is. Okay, so cos x square plus 5 as it is into d by dx of x power n. This is of the form like that only. Now, so we will be using u plus v the whole dash, that is d by dx of u plus v is equal to u dash plus v dash. Yes, so what we will be doing here is that this will be iu, that is u is equal to x square and v is equal to 5. Okay, so now first d by dx of x square. So d by dx of x square first and next plus d by dx of 5. Okay. So in the next step I will have cos x square plus 5 into, so we know the formula d by dx of x power n is equal to n into x power n minus 1. This is the formula for d by dx of x power n. No, so I will be using that formula here. So what is n here? It is 2. So 2 into x. x power 2 minus 1. This is the formula, no? N minus 1. So 2 minus 1 is 1. So I am leaving it as it is. So here d by dx of some constant. D by dx of any constant is 0. Why? Because just keep this in mind. For if it is any constant, it means, for example, we had 5 here. Let us take that itself. So it means that x power 0 is equal to 5. Yes, because x power 0 is 1. So if we just differentiate that, what we will have, no? N, this value of n will be 0. So 0 into 5x power minus 1, because 0 minus 1 is minus 1. No, so 0 into anything is 0. So only the derivative of any constant is 0. So we can have a 0 here. So therefore the final answer will be d by dx is equal to 2x into cos x square plus 5. This is your answer. First, we will be differentiating for sine. Then we will be differentiating for the variable or any function that is inside sine. And then we will reach the final answer. Question 2. Cos of sin x. So as we did for the previous question, we will be writing y is equal to the given function. Here the given function is cos of sin x. Okay, so now we will be differentiating with respect to x. So one more note where what you have to do is that you have to mention one thing which I skipped in the question 1. So the important thing that should be written here is that we have to say differentiating with respect to x. We have to mention this. If not, the marks might be reduced. So differentiating with respect to x is must. So in the next step only we will be writing dy by dx. So dy by dx is equal to d by dx of cos of sin x. Okay, so now this sin x is theta. Sin x is theta. For your understanding, I'm saying, okay. So now leave this as aside. So we know the formula d by dx of cos theta is equal to minus sin theta. So you have to write it there. So first we will be differentiating for the entire term, that is entire function. So what is my function? Cos of sin x. So here theta is sin x. Theta should not be changed. So now I will have minus sin. What is my theta here? Is theta changing in the formula? No. So my theta should be as it is. What is my theta here? It is sin x. So sin x into, I have to go to the next function, that is theta. So my theta here directly I can just write theta. For your understanding, I said theta. So now we will be differentiating d by dx of sin x. Okay, so in the next step, you should not write this as sin square x. So sin x is a function of sin. Okay, so you should not write it as sin square x. It should be minus sin of sin x. This is not multiplication. So here we know that d by dx of sin x is equal to cos x. So into cos x. So you can write the final answer as dy by dx is equal to minus sin of sin x into cos x, or cos x minus cos x sin of sin x also. That's right, because this is all product, so that isn't a mistake. Question 3, we have to differentiate the function sin of ax plus b. So solution. So let us write the y is equal to sine ax plus b, that is the given function. So now we have to write differentiate with respect to x. So we have to write it as it is. So dy by dx is equal to d by dx of sine ax plus b. Okay, so d by dx of sine theta is equal to cos theta. This is the formula. So we have to write it as cos of ax plus by, because this entire term is theta. So cos ax plus b into d by dx of ax plus b, because this is a chain rule. Now first we differentiated the entire function and next the algebraic function of sine. So ax plus b. So here a and b are any constants. Wherever a, b is given, unless and until it is mentioned that a and b are variables, they are always constant. So we will be writing it as dy by dx is equal to cos ax plus b into, so here we know the formula, d by dx of x power n is n into x power n minus 1. So what is the power of x here? It is 1. So 1 minus 1 is 0, which is again 1. So a alone I will be writing it here. So in the next step, I will have d by dx of b, which is a constant, that is 0 plus 0 only. No? So that isn't anything. So my final answer will be a into cos ax plus b. This is my answer. Question 4. A function secant of tan of root x is a function that is given and we have to differentiate it with respect to x. A solution. Write the usual form, y is equal to secant of tan of root x. Okay, this is a function that is given. So this function will be solved with the help of chain rule. So again we will write differentiate with respect to x. Always it is necessary to write this differentiate with respect to x or with respect to any variable that we are deriving. So I will write dy by dx is equal to, so we know the formula, d by dx of secant theta is equal to tan theta into secant theta. Tan theta into secant theta. No? So this theta value here, it will be for secant, the theta value will be tan of root x. This is the theta value for secant function. Okay, so I will write tan of tan root x into secant tan of root x. Okay, so for this secant, it is over. Okay, so in the next step, what you should do, you have to differentiate this function, that is theta of secant. No, so in the next step, this is multiplication. So let me write it here because I don't have place there. So d by dx of tan of root x. This time need not to consider secant because this is a chain rule. First we will be differentiating the entire term and then the next function and then the next function, we will be going like that. So that's what it is named as chain rule. So we know the formula, d by dx of tan theta is equal to secant square theta. So dy by dx is equal to tan root x. Again I'm saying this is not tan square root x. Okay, so it is tan of tan x secant tan root x into, I don't have place here, so let me write it here itself. So what is tan root x? It is secant square root x. Secant square root x into, so we finished the entire function and for tan, and now we have for root x. So now I will write d by dx of root x. Okay, so we know the formula d by dx of x power n is equal to n into x power n minus 1. So I will be writing this as dy by dx is equal to tan of tan root x into secant tan x, tan root x, into secant square root x into, so here what is the value of n here? X power 1 by 2 is root x, no? So I will write 1 by 2 into, what is my x, n minus 1, no? So 1 by 2 minus 1 is minus 1 by 2. Yes, so minus 1 by 2 means it is the root x should be in the denominator. So I will write 1 by root x. Okay, so now I will have my dy by dx as tan of tan root x into secant tan root x into secant square root x, the whole divided by 2 root x. So this is my answer. Question 5. The function given is sin ax plus b divided by cos of cx plus d. So solution. So let us write this as y is equal to sin ax plus b divided by cos of cx plus d. Okay, so now till now we were just seeing a function, a simple function that was given, and we have not learned about the division. Okay, so now we are going to learn the new method of deriving, that is division. So we know we have already learned the formula u by v the whole dash, that is d by dx of u by v is equal to u dash v minus uv dash by v square. This is the formula. So the d by dx of u into v minus d by u into d by dx of v divided by v square. That is nothing but, let us write, differentiate with respect to x. So we will have dy by dx as, so what is a u? So my u is equal to sin ax plus b, and my v is equal to cos cx plus d. Okay, so let me just denote with a square bracket, that isn't a mistake. So first I should have u dash, no? So that is d by dx of sin ax plus b. So as I thought you, d by dx of sin is cos. So cos ax plus b as it is, and then I will be differentiating this ax plus b. So d by dx of ax is a plus d by dx of b is 0. So I can just leave it like that. So a into cos ax plus b is u dash, and my v should be written as it is, multiplication. So cos cx plus d minus, what I should do, u. My u should be written as it is. So sin ax plus b into, now I have to what, differentiate v dash, no? So v is here cos cx plus d. So d by dx of cos is minus sin. So I will write sin cx plus d. Okay, and I have to differentiate this part, cx plus d. So d by dx of any constant is 0, and my d by dx of cx is c only. So this is my numerator. So now I have my denominator. No? So don't forget with the numerator, denominator, that is v square. Here is my v. So my v square will be cos of cx plus d the whole square. So I can write it as cos square cx plus d. Okay, I think you will be very clear with this part. Let me write it in a different color so that you will be able to differentiate it. D by dx is equal to, this all should be written as it is, but only thing is that we will be splitting these two. That is, the subtraction sign is here. So that one we will be splitting it. That is a into cos ax plus b into cos cx plus d divided by cos square cx plus d minus, so let this be as it is, okay? So sin ax plus b, so let me have it as plus itself. So my minus into minus is plus, no? So my plus c into sin cx plus d, the whole divided by cos square cx plus d. Okay, so now what I should do is that dy by dx is equal to, can I cancel any term here? Cos cx plus d is here, cos cx plus d is here. So I can just cancel this term and this power. So I will have a cos ax plus b divided by cos cx plus d. Okay, plus c into sin ax plus b. I don't have cos cx plus d. So what I can do is that sin cx plus d I have and cos cx plus d I have. So sin theta by cos theta is tan theta. So let me write it as tan cx plus d divided by cos cx plus d. We have 2 cos cx plus d. I am taking only one out. Okay. So the final answer will be dy by dx is equal to a cos ax plus b into 1 by cos cx plus d. That is this is of that formula. So 1 by cos is sec. So secant cx plus d plus c sin ax plus b into tan cx plus d into, I don't have place here, so let me write it down. So 1 by cos is sec. So secant cx plus d. So this is my answer. Question 6. The given function is cos x cube into sin square x power 5. So in the previous sum we saw the derivative for division. So now we will be deriving for multiplication. Okay, so let me write this as y is equal to cos x cube into sin square x power 5. So solution, let me write it as differentiate with respect to x. Okay, this is very must. So let me write it as, so here also we will be using uv method. No, so uv the whole dash is equal to u dash v plus uv dash. So this is the formula. No, so we will be writing this as u is equal to cos x cube into, sorry, v is equal to sine x sine square into sine square of x power 5. So this is our u and this is our v. So what we will be using is that dy by dx is equal to u dash v. No, so u dash is what? Cos theta. D by dx of cos theta is sine theta minus sine theta minus sine. What is my theta here? X cube. So now in the next step, what should I do? I have to take the derivative for differentiation for x cube. So this is of the form x power n. So n into x power n minus 1, the derivative. So that is 3x square. Okay, into what is my v here? It is sine square x power 5 plus u v dash. So u is cos x cube into my v dash. Okay, so when you have the trigonometric functions with power, then what you should do is that first you have to differentiate that. That is, you will be removing the square. We have not learnt any formula with the power 2. We have learned the derivatives formula only for power 1, that is d by dx of sine theta or d by dx of cos theta. We have not learned d by dx of sine square theta or anything. So what you should do is that you have to remove the power. In order to remove the power, what you will do? First, you will be bringing this power this side. That is, as we do for d by dx of x power n, we will be doing it in the same form. So 2 into sine power 2 minus 1 is what? 1. So we will have sine power 1 into x power 5 into, now we will take the derivative for sine theta, that is cos theta. So cos x power 5 into cos x power 5 into, I have to take the derivative for x power 5. No? So the derivative of x power 5 is 5x power 4. So our final answer will be dy by dx is equal to minus 3x squared sine x cube into sine square x power 5 plus, so I have 2 and 5 here. So I can just take these two. So what I will do is that 10 into, what is this? X cos x cube into sine x power 5 into cos x power 5 into x power 4. This is your answer. If you want, you can just rewrite it saying that 10x power 4 into cos x cube into sine x power 5 into cos x power 5 minus 3x square into sine x cube into sine x square x power 5. You can write like this also, or if you just leave with this, that's okay. Question 7, a function is given. We have to differentiate with respect to x. So let me write it as y is equal to 2 root of cot x square. Okay, so now we have to differentiate with respect to x. So now let us write it as dy by dx is equal to 2 as it is, and we have to take the derivative of this. So as I said you in the previous question, we have not learnt any formula, and there is no formula for derivative of cot square or root of cot and all those. So first we have to consider this as x power n only. So as I said, always just remember d by dx of root x. If it is like this, then you will have 1 by 2 root x. This is the derivative. So always keep this in mind so that this will be helpful. So I will have 2 into my constant will be as it is, and The derivative of root of cot x square is 1 by 2 root of cot x square. Okay, so this is over. So now for root of cot x square is over. So now what I have to do, I have to differentiate for cot x square. Okay, so I think let me repeat it again. See, when the power of the trigonometric function is other than 1, you will be taking that trigonometric function as x and differentiating that x, and next you will go back to the trigonometric function. So here it is cot x square, so we will be differentiating that. So let me write it step by step. D by dx of cot x square. Okay, so since this is new, I have written one more step extra. So 2 and 2 will get cancelled. So this will be root of cot x square into d by dx of cot x is minus cosecant x, minus cosecant square, and what is my theta here? It is x square. And as we know, by chain rule we will be differentiating this x square also. So what is the derivative of x square? It is 2x. Derivative or differentiability, both is same. So what I will do is that dy by dx will be written as 2x into minus cosecant square x square divided by root of cot x square. So you can't just leave it like this. If you leave it also, it is not a problem, but still you can simplify this, no? So you have to simplify it. So now let us see the simplification of this derivative. Here the differentiation or derivative is over. So now let us simplify this equation. So dy by dx will be as it is written. So now let me keep my numerator as it is, that is 2x into cosecant square x square divided by, my cot will be simplified as cos x square divided by sin x square. Yes, so this is of the form cos x square divided by sin x square. So now I will have it as minus 2x cosecant square x square into, I will be taking this as root of 1 by, root of 1 is 1 only. So 1 by cos x square divided by sin x square. Okay, I think you will be clear till here. So now in the next step, 2x into, what is cosecant x? It is sin x. Now so 2x into sin square x square. Okay, so this one will be rewritten as root of sin x square by cos x square. Okay, so I will be writing this again as minus 2x, root will be splitted, so sin x square divided by sin x square. I will be splitting the sin square x, so sin x square into sin x square into root of cos x square. Okay, so now I can just cancel this, no? So again I will be writing this sin x square as root of sin x square into root of sin x square. So this and the root will get cancelled. Keep that in mind. So I will have minus 2x divided by sin x square into root of sin x square into cos x square. Further, this can be simplified with a formula. Sin 2x is equal to 2 sin x cos x. Okay, so we have only sin x cos x. So this will be of the form sin 2x by 2. So minus 2x divided by sine x square into root of sine 2x by 2. So further dy by dx is equal to minus 2 root 2x divided by sine x square into root of sine 2x. That's it. Question 8, a function is given cos of root x. So solution, so let me write this as y is equal to cos root x. So therefore I will differentiate with respect to x. So my dy by dx is equal to, so directly I can take from d by dx of cos theta, which is minus sine root x. So next step I have to differentiate for root x. So as I said already in the previous question, derivative of any root will be 1 by 2 root x. That's it. So or any function. Okay, so that's it. So let me rewrite it again. So dy by dx is equal to minus sine root x divided by 2 root x. That's it. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.